And how, finally. So I'm going to demo you how I imagine this to be done. And yeah, hopefully nothing breaks while I do it, as on any demo. 1 second. I got this Zoom box that's in the way. How do I get rid of the, oh, there we go. Right, so I'm going to go through my repo first. So this repo is basically the folder structure of like your threat model. That's how it should look like. So we have a README document that can be inside a threat modeling repo, or it can be inside a folder. And the README document basically just describes the whole process that I just said. So we trigger the threat modeling process with the design phase of the software development lifecycle. We clone this repo into a repo where the threat model will live. I meant folder. So bear with me, this is all new. So I'm going to go ahead and improve this later, but I wanted to have this ready. So at least there's something I can show to you guys. And any feedback also on this, please, send me pull requests, create issues. Happy for any participation. So so we create an environment for this. We communicate with the devs, get them to complete the threat modeling questionnaire, which I'll talk about later. We review the architecture diagrams and we trigger a session. Now, how to use this? So we need Anaconda for this because we're going to be using Jupyter notebooks. And we're going to create Anaconda environment with an environment.yaml file that's inside this repo, and we activate that environment that has all our dependencies that we need them. And then once we have done the initial assessment, we create diagrams as code, and then additionally, Wordly maps as well, because we can use Wordly maps to create a strategy on remediation and risk. Now I'm going to go into the actual Jupyter notebook. So as you see, it's here, but what I'll do is I'm going to go to the Jupyter notebook on my screen. So this is how it all looks like. So this first piece of code is just to hide the input code what we want to present. If we want to present this threat model to like management or something, we can just hide all the code and it will come out nicely. I'll show that later. So the theoretical part of the threat modeling, and this is why I call it a hybrid, is this. So there's two parts of it, and I'm planning to separate them later actually into the prep bit and into the output bit, but at the moment it's all together. And what we do is we get the devs to complete all of these questions about their application. It doesn't have to be about the whole application. It can be just about the feature that we're threat modeling, because as I said, it's better to do a few smaller ones than a huge chunk one. So we complete the whole thing here. We list the threats, but that's just from the developer point of view, what they think when they're coding the application. Do they think there's any threats to the application? So this is all like prep work, because also from the security side, once the dev has answered all of these questions, it doesn't have to be dev, it can be the architect or DevOps engineer, depending on what part we're modeling. So then as security, you can review the whole thing, and you can also come up with any follow-up questions, and you can list it all here. And this bit is actually the output, because after you do the whole threat model, you have your threat modeling session, you list here the threats, the risks, the actors, the controls. What I'm planning to do is also make it more into a table and put it at the end actually of the Jupyter notebook. So that's how the theoretical part is, and this is all based on the OWASP threat modeling methods. And I've put here a excuse me OWASP cheat sheet that everyone can see as a reference. So also here we can put the owners of the risks that we identify, we can put some controls that we identified and considerations. Also, what I'm planning to add here is facts, actually, because it's important to state some facts so we don't have to go back to those facts. So, for example, there might be a threat that we considered, but we decide it's not a threat because of some certain facts about the application itself, of some certain authentication, authorization mechanisms that are in place, for example. So it's good to log these. So if we do any subsequent threat models based on that, on top of that, that we can just come back to these facts and just say, well, this was already considered and it's not a threat, so let's move on. So once we have that, we get on to creating a data flow diagram. Now, ideally, we want the development team to start doing these. And actually, they should tie in with the architecture diagrams, because if an architecture diagram is done correctly, it will show some flows in the application itself. So this is a good way to trigger some good quality architecture diagrams if they're not already in place. So what we do is we use a library called diagrams, and all the dependencies for diagrams are in the environment .yaml file. So what we do is based on a Python code, we create a data flow diagram. It takes a little bit to learn. It takes a little bit to load over the icons. But once we have a few of these diagrams, it becomes really easy and straightforward from there. So anything that we want to add or change, we don't have to think about reassembling the whole diagram. But what we do is we just add our components, whether they're in a cluster, because putting them in a cluster will help us with trust boundaries as well. Because if we have like a couple of things that are inside one trust boundary, or if we want to even represent a Kubernetes cluster, we can all put like within the cluster, or they can be outside the cluster like these guys here. So once we have created a diagram, we can, and we've done our threat modeling session as well, what we can do is proceed to a kind of risk mitigation strategy. And we can do that by using wordly maps, also with code. So basically what we do is we go for, we use this little framework for wordly mapping in code. And again, list the anchors, list the components, capture the flows, and we have a wordly map. Now I'm going to execute this whole thing so that you can see what I'm talking about. Any questions before I move further? I guess that's a no. Let me just fix my camera. Okay, cool. So I'm going to execute everything. All right. So this is how it looks like, nice and clean when we execute the whole notebook. So then we have, as I said, the theoretical part, which I'm planning to divide in two parts, the prep part and the output part. And then we have our data flow diagram. So this is how it looks like when we use diagrams. As you see, the components are really nice and clear. We have some icons. You can even import icons. You can designate your trust boundaries as well. And you can even change the colors of the edges. And you can play around with that too. And then this is how our wordly maps look like. So in relation to that, the reason why I'm showing you this specific wordly map, even though I'm talking about creating a wordly map for a risk mitigation strategy, in this scenario, I wanted to present this specific map. And the reason why I wanted to say is why I also think creating these diagrams as code should be quite useful. And the reason is for the architectural team and any new development engineering on the application itself, we need diagrams. Also for troubleshooting, if things go wrong in production, we need good quality diagrams, right? As InfoSec, we also need diagrams. So therefore, in our wordly map, for those who are not familiar with wordly maps, we have as anchors InfoSec and architecture team. So these anchors have needs, and the needs are threat modeling and diagrams. InfoSec has the need diagrams of threat modeling. Architecture team and InfoSec, they both have diagrams as a need for threat modeling, or for the architectural team for further engineering efforts, troubleshooting, and so on. So therefore, we can see here that good diagrams can be obtained from good architecture diagrams. And the way to obtain them is to have engineers create good diagrams by having those skills. Because sometimes, engineers are brilliant at writing great code, but maybe not so great at creating good diagrams of the code itself, of documenting the flows, of actually visualizing the flows. Because some people are not even that visual. Some people are very contextual, so they can write brilliant code, but they can't visualize it all that well. So we need to teach them those skills. Also, there needs to be a company-driven initiative to get those diagrams in place. So if we pull those two things to the right, which means that we carry them inside with their evolution, we carry them more to the right, which means we make them more commoditized, we make them more of a product, make them more mature. That means that our threat modeling, which is in the genesis phase, which is in the immature phase, can also be pushed to the right and make it more mature and make it, more of a product and a thing rather than what it is now as a bespoke creation. So this is what happens basically. This is the evolution that I wanted to show. If we make better diagrams, if we keep making these diagrams, and that's what I'm saying, rather make a few small ones than, a huge chunk that nobody understands. We keep making them. And if we get the devs in a good place where they are actually able to make good quality, and we insist on that, we can actually get our threat modeling and data flow diagrams also in a good place. So to kind of capture the whole thought process behind this is a kind of a hybrid between classical threat modeling and threat modeling as code to bridge the gap between the security team and the devs to make it easier for everyone. We have, a versioning system which captures our continuous risk assessment, our continuous threat modeling. No need to come back to old threat models. We just carry on top of that. We create multiple smaller threat models. Same for diagrams. We create them as code. And then if we want to zoom in on any mechanisms right here that happen, we can create a separate threat model on as a zoom in, but then it's easier because we already have the code for this big diagram and we don't have to do it all over again and change everything. And then also it helps when we have worldly maps as a strategy on how we're going to action this, because a lot of times this threat modeling, which becomes like an academic exercise, we'll do it, but nothing gets done. So to help not only security, but the whole company, it's important to show why the action items from the threat modeling session are important and how they're going to help the whole company. So therefore, we can use worldly maps that can all be in this Jupyter notebook. So yeah, this is basically my little framework. As I said, please, bear with me. I'm going to make it better. I'm going to work on some additional stuff. Feel free to put issues there, what else you'd like to see there, suggestions, or create a pull request. And, I'll have a look and hopefully we can make it a collaborative effort.